Okay. We don't want to be on Firefox. We do want to be on Google. So here we are. I'm trying to make things a little simpler for us in our modules. So ideally our module should have today's date, 9/15, and be in the order that we'll work on it. So there is a little warm up here. It's just a simple question. What's one of the technology eras that we talked about for our project? Or technology ages?
I wasn't here last class, so I kind of missed out on it, but I'm gonna look at the recording meeting.
No problem. I'll go over quickly what the project is. Basically, our project is going to be, we're looking at technology through the ages. There's a worksheet that tells you what those ages are. It's like Stone Age, Bronze Age, Iron Age, Renaissance, Industrial Age, Information Age. The idea is you're going to curate a museum exhibit of technology through the ages. You need to create a slideshow with your name on it, and then one card for each one of the ages and one device or a piece of technology that you think is interesting. I'll go through it in more detail, but that's
Okay.
what we're basically doing.
Thank you.
No worries. And the great news is our recordings are up. So that is happening. I hate to say, they're not beating down the door for 1 minute before class. There's some. It's like people coming to your party. You feel bad. Nobody shows up to your party. Welcome, welcome. Welcome, welcome. I've got my new second screen, so that's why I keep looking adoringly over to my right. Welcome, welcome. There is a warm-up today. I've got it up on screen. So when you look in modules, it's right here, FOT 915 warm-up. Today's going to be a fun day. Scotty. Cheyenne. So one word of advice while everyone's in here. I've created a link to a playlist of all our class lectures so far. So when you click the link, ideally you'll be taken to my YouTube site and you'll be in a playlist that has every lecture in order, most recent first, going back to last. You can click on whichever one you want to watch. It should be very easy. Let me know if you have trouble with it. For the early ones, the first 4 approximately, I believe you're going to probably want to skip ahead about 5 minutes to see where I start talking, because I start recording while I'm doing attendance. So you may want to do that. Hopefully moving forward, I will actually trim the videos to make them so that they don't have a big lag at the start. I know that's annoying when you don't know when it begins. You got to watch the whole thing. Welcome. So I was saying there is a warm-up. If you want to get to it, we're about 4 minutes in. We've got a pretty good crowd, but not, I'm still missing about a third of our people. I've got about 23 in here. Like I say, it's like having a party and people aren't showing up. It's very sad. Let me get started and we'll just try and keep my ear open if anyone else comes in. Okay. So one of the things I'm trying to do to help us is create the modules in a little clearer format. So ideally, every day we have class, there will be a module with today's date on it. Look. All right, now they're flooding in. Somebody loves me. Okay, welcome, welcome. I'm just saying that we have a warm-up in today's module. Ideally, I will be making these modules that will have the date of the class, a little something about what we're going to look at. Today, we're going to look at technological problem solving and touch on our big project for Artifacts Through the Ages. Okay, so take a moment to do your warm-up. I'm just going to ask a couple people what they came up with, and then we'll talk about the project because I know some people need to be reminded. So some people are saying the module isn't here for you. Where are you looking?
You have 2 warm-ups for them, so.
This is so weird that in my world, I created one warm-up and there is one warm-up. So when I look, this is the only warm-up that exists. This is when I look in modules. So I click modules. I go down. This is the only warm-up. Ideally,
that one doesn't work though. Like, I don't know. You have 2 warm-ups. One says technological era. That one, that's the one I used and it works.
okay.
So that one doesn't.
Let's go in. So when I look at assignments, I go down here to practice and preparation. It should be warm up in a technological era. Oh, there. That's what's causing trouble. Why would that be down there? That's so strange.
I don't know. For me,
Okay, so
when
hang
I
on. Let me get people over into my other screen because that one's, they're both published. So which one are you saying works? The one that says warm up or the one that's warm up technological era?
The one that says technological era.
Okay. Then what I'm going to do, probably going to cause trouble, but trust me, I'll just give everyone credit. This is not a difficult warm up. So let's remove that. And then we will give you a window into my world of how we do these things. I need assignments. Come on, assignments. Why do they move around for every single page? How would that be? What the heck? Okay, so now I'm going to copy to foundations. Okay, so now let's go look at the magic list and see if what I've done actually translates. Of course it doesn't. It's probably because let me refresh. Refresh. Come on. Okay, well, it's not showing up in here. So if you just go to assignments, oh, hang on, here we go. So this is my bad for not double checking everything. If you go to assignments, look at the top of the practice preparation. This is our warm up. So it's just name one of the technological eras we'll be illustrating from our Technology Through the Ages project. Is it showing up for you yet in modules? The problem is I think it takes time. There. Okay, so now the module is back up. So that should be working. I don't know why sometimes this thing creates two and I'm not controlling the other. So let me look at my giant view of people. Somebody who's feeling frisky this morning, can you tell me technological era?
The Stone Age.
Yeah.
Go ahead, you can just share out unmuting.
Renaissance.
Okay, that's a good one. Anyone else?
Silicon Age.
Silicon Age. What's the other name for that?
The Technological Age. Or the
Ooh,
Technology Age.
That's
Yeah.
a different one. Information age.
Information.
I think right now is the information age because so much of our technology and business is run about information. Okay, let's take one more. What's one more good time period that you like or have looked into? Somebody be brave.
The Bronze Age.
Bronze Age. What was special about the Bronze Age?
I'm not really sure.
Okay, well, don't worry. When you start doing your research, you'll find out things. What was special about the Bronze Age was that that's the transition from the Stone Age into sort of more modern times. Bronze was made by alloying copper and tin. Tin has a very low melt point, so it's easy to work with. Copper has a fairly high melt point, so that was much more difficult for ancient peoples to work with. By putting the two together, you made a substance that had the strength of the copper, but the melt point of the tin. That bronze has a relatively low melt point, and this allowed people to have a metal that they could shape and they could mold. And this meant that they had a lot more flexibility in what they could create than what you could create out of stone. Okay? So those are just ideas. So today, I am going to click on we are going to look at the lecture in PowerPoint 2. I already have it teed up. And here we go. Oh, no, before we do this, that's right, some people didn't know. So does anyone have questions? Something I did want to do this morning was talk about, just quickly, does anyone have questions about our big Technology Through the Ages project? Okay, I'm going to be a little quick here because my thought is, let me just read through what this is again. I know somebody wasn't here last time. So we are going to be doing a project that is going to be due next Tuesday. You have a whole week to do this. So the background, the progress of humanity has been characterized and divided into a series of ages. A few of the ages are named after some of the common elements of technology of that time. These ages are known as the Stone Age, the Bronze Age, the Iron Age, the Renaissance, the Industrial Revolution, and the Information Age. So what you're going to do is create a virtual museum presentation of artifacts from the different time periods or ages. You will research various tools and technological resources that were developed and used during those different technological ages. After you conduct your research, produce a PowerPoint presentation or Google slideshow that contains images and descriptions of objects from each major time period listed above. The guidelines. You're going to create a slideshow that describes one object from each of the major time periods: Stone Age, Bronze Age, Iron Age, Renaissance, Industrial Revolution, and Information Age. Describe the purpose of your object, what it did and why. You're going to do one object from each major time period. If you're really ambitious, you can do more, but you will get full credit if you have just one object per slide. It's probably going to give you more space on the slide to do one. If you wanted to do multiples that you really love an era, that's great, but you don't have to. Next, describe the function of this technology. How did it work? So that's for each major time period. Describing the purpose and the function seem pretty close. So just be robust in your letting us know what this is, how it worked, why it possibly got invented at this period in time. Explain why each item was developed during this period in time, which it was used. There we go. Why was this developed now? Those kinds of things. Like the telegraph. The telegraph was invented during the Industrial Revolution because people's need for communication was incredibly great, and this provided a way to send messages over long distances that had not been invented before. The last thing on our project is you're going to need an image of each item, each technological item from each age that you describe. For the older ages, they're probably going to be drawings or something like that, or a representation. Save your presentation for your records and submit a copy before the due date and deadline listed on the course calendar. So that due date is going to be next Tuesday. I believe that is the 21st or something. It is the 22nd. Tuesday the 22nd is when this is going to be due. So that's it for our technology project. We're going to work on this more next week, but we've got some stuff to cover here in our fabulous lecture. So today is Tuesday, September 15th. Our agenda is to review Technology Through the Ages, done. And then we're going to talk about technological problem solving. Due today is, I should have added it, your warm up. Just picking one of the technological eras. Technology Through the Ages project is going to be due September 22nd. So that's the only thing that you guys have outstanding right now. Our goal is you will be able to define the difference between a technological problem and a naturally occurring one. What does that mean? Okay, oh, hang on, I should be in present, shouldn't I? Now you are seeing this in present mode, right?
No. Wait, also, I have a question.
Hang on, are you not seeing what I'm doing? Wait,
No, it's not on.
And your
Is it on
screen.
the bottom?
all right, hang on. I don't want to exit. Where are my Zoom controls? Because I'm supposed to be presenting my desktop. Okay, that's the problem. All right. Now, I'm sorry, Chrome just seems to be acting very fickle these days. That some days when it pops out the lecture, you can see it and others you don't. So I'm just trying to present my desktop. Okay. So now, is everyone seeing what we're looking at? The full screen slide, Tuesday, September 15th.
Yep.
Great. Okay, today is technological problem solving, a closer look at human innovation in action. I don't know what this brick wall is or why this thing is coming in at an angle. Technological problem solving. Using the term problem solving means so many different things to so many different people, fields, and disciplines. I'm going to open it up to the team. Let's get a couple different ideas of what you think problem solving is. What does problem solving mean to you? Anyone who's feeling brave can volunteer. If I don't get volunteers, we will start picking from the giant screen. So who's feeling brave? Just what does problem solving mean to you?
Trying to find a solution.
Okay, what is the result of problem solving?
A solution to your problem or like a compromise, maybe?
Okay, we'll see as this goes on. It's an interesting thing that we sort of figured out in the last class, the idea that you get a benefit out of solving a problem. Typically, problems that mean something to you are problems that if you solve them, you will get a benefit. Okay, so let's hear one more. Does somebody else have an idea of what problem solving means to them?
A means to become more efficient.
That is an end result, but problem solving is more like our engineering feedback, the engineering development loop, that the first step in solving a problem is you've got to figure out what the problem is, right? Sometimes that's not easy. Sometimes it's very easy. We're going to talk about the difference today of problem solving a technological problem versus a natural problem. Which one do you think is easier to solve? A technological problem or just a problem in the natural world?
A problem in the natural world.
Is easier to solve than a technological problem?
Yes.
Okay.
I think so.
All right. Anybody else have an opinion?
I think the opposite, that a technological problem would be easier because if you're trying to solve a bigger problem in the natural world, it might not be easy to fix something that's already natural. Like you would be making it unnatural.
Okay, that's what I was aiming for. Mackenzie, you're not wrong. I think that either one can be easier or harder, but typically the problem with problems in the natural world is they have multiple causes. They have like earthquakes. How do we solve earthquakes? At this point in time with our technology, no one can solve an earthquake. Earthquakes are too complex for us to predict accurately or be able to come up with a single resolution that's going to solve the problem. The idea is that ideally technical problems you can usually figure out what technical issue is causing that problem. Once you've figured that out, ideally you can address that issue, and if you do, you should solve the problem. And thus the idea is that a technological problem is easier to define than a natural problem, that it is more contained than something in the natural world. The problem with the natural world is so many different things affect it. You know, like the weather. How do you predict the weather? We've gotten very good at that. That used to be a real problem. You didn't know what the weather was going to be every day. People worked and worked, and it was very difficult for a long time. But now technology has actually, through the use of computers, created a way that we can actually predict the weather relatively accurately. Let's say within 80%, depending on where you are. That is a big improvement. But the weather used to be thought to be too big a system to be able to predict. There are too many variables influencing how the winds blow, where the rain is going to fall. But computers have solved that. All right, we're moving on. So I'm going to not read the headlines because they're always the same thing. Technological problem solving. Solving a problem in math class. Does the teacher relate that to actual problem solving? When you guys are typically doing a math problem, does your teacher set it up in a way that it has real world applications?
Yeah.
Okay, like what's an example of that?
Like in geometry, my teacher used to like do problems with like shapes in real life and everything. Like you have to find the circumference of, you know, whatever circle.
The Pantheon in Rome, which
I
is
don't know.
a Colosseum
Yeah.
or something. That,
Yeah, I don't know.
okay,
It's like
that's great, because those are problems that you're solving that help, that do give you a benefit. That I think what it's trying to get here is that idea that if you're just trying to solve x cubed plus y cubed equals 2ab, or 2xy, those problems are solving that is not really producing a benefit for you, other than you got the right answer, you're continuing your education, those kinds of things. I think an example where it does touch you is that idea that, like, you're learning how to measure the circumference of a building. Or an example from the previous class, I had a student who lives like 3 miles from Blair. So she could walk to school, but it would take her about an hour to do that. So to solve that problem, she figured out that there was public transportation, or if her parents' schedule worked, she could get a ride to school in the morning. So she solved her, time, rate, and distance problem. If Cheyenne lives 3 miles from the school, is it going to be quicker for her to walk to school or to get a ride? So that's solving a problem that made a real difference for her. A lot of times the problems that we do in school, like I think this next one, how about the teacher in language arts who asks you to find some meaning of an author's writing? Is that a problem that needs to be solved? Does that too mean problem solving to them, to the teacher? What do you think about that? Is finding the meaning of a passage really problem solving? Does that give you a benefit?
Kind of, because if you're gonna try to find the meaning of an author's writing, it may better your understanding of it.
Of the author, the passage that you're
of-
reading?
Yeah.
And also, it may just be pertinent to your life today. Pertinent means that it applies to your life today. So maybe it's someone writing about the Spanish flu pandemic a century ago, and some of the lessons they learned may be critical to you surviving right now. So that is solving a problem that touches you more directly, but it's also that problems change given your perspective. to a literature teacher, understanding the meaning of a passage that they've assigned is critical. That is a problem that needs to be solved for their students. The students need to understand what they're reading and why is that important to them. How is that going to help them be a more well-rounded person, help their perspective?
If you have a dog, turn your volume up to see what their reaction will be for the following sounds. Or don't, I can't really tell you what to do.
What was that? I'm not sure, but we think it's coming from Julie. I never read the back of the shirt. Middle school English language arts teachers, we solve problems you didn't know you had in ways you don't understand. So that's nice. That sums up that the world of the middle school English teacher is probably very different from the world that we average people live in. The problems that they need to solve may not be problems that we feel we need to solve, but they're no less important in how we go about them. All right. One important fact about technological problem solving is understanding that not all problems are technological. Okay? Not all problems are technological. I love this quote from Einstein. Let's unpack this. We can't solve problems by using the same kind of thinking we used when we created them. Why is Einstein writing that? And let me hear a couple of your interpretations of what that means. We can't solve problems by using the same kind of thinking we used when we created them. What's he asking you to do to be a good problem solver?
Think outside the box.
Change your way of thinking.
What was that, Dina?
I said think outside the box.
Okay, so Julie, what was the next one? Did you have an idea, Julie? Diver?
No.
Sorry, I thought that you were unmuted. That's how I tell who's talking, is that it, let me try another screen. I'll see if that works better. It's so hard to figure out who's talking these days. Why doesn't mine go into, I can't get the screen where it gives the presenter the big one. All right. So think outside the box. What else does that mean? This is something I've talked about a couple times when we go into our breakout groups. What's important if we're trying to solve a problem and you're going into a breakout group?
Communicating.
Communicating is certainly important. That you, for one, you need to feel comfortable enough with the people that are in your room that you have a desire to communicate with them. We need to still keep working on our team building so that everybody gets to know each other a little better. Because I know a lot of people are still keeping their cameras off in breakout rooms and even their mics muted. Once you're in a breakout room, you should be able to take the mute off your mic. If I created our problem that we're doing, and I can't think of a solution to it, what do I need in the room with me in order to come up with an idea of how to solve my problem? I created the problem and I can't think of a solution. So I'm going to go into a room with 4 other people. Who do I want in that room with me?
People with different ideas.
People with different ideas. And typically, that's going to mean people that look different than you, people that sound different than you, people that can think different than you, and possibly in annoying ways. But you also want opposite sexes, that men and women, not to be stereotypical, but the book Men Are From Mars, Women Are From Venus has a certain basis in truth that men and women process differently, that the way they look at the world and analyze it is different. Again, I don't want to be stereotypical, but I'm just saying that these are the ways that you are going to find an angle on your problem. Because if I created it, the way that people thought to create the problem is not what's going to help you get out of the problem. You need to think outside the box. You need to come up with novel solutions to create the best solution to your problem. I was a biology major, and I had to take chemistry, physics, calculus, the whole 9 yards. One of my favorite concepts from chemistry is called the elegant solution. These are stories about how people discovered things like xenon gas or whatever, that an elegant solution is the simplest answer that fits all the parameters of the problem. An elegant solution is the simplest solution. So when we're problem solving, you need to expand your thinking in the initial phase when you're brainstorming about how can we fix this. You need to listen to the people in your group. You need to listen to people that you wouldn't normally listen to because they think differently than you, because their ideas might be annoying how they present them. But listen because they have different perspectives and different techniques of doing stuff, and you'd be amazed at what different people can come up with for solutions. There are things that you didn't dream of that can be the perfect answer to your problem. Somebody may have experienced this in the country where they come from. Somebody's family traditions may have something that helps you. You never know where your answers are coming from. So you've got to be open, and we've got to work with diverse groups to create the best solutions. That is a pretty well established fact, that having diversity creates better solutions to problems. Okay, what's happening in this picture? Is this a technological problem? Take a minute and think about it. So I'm pretty sure this is a photoshopped picture, that this is not reality, but I have worked with very similar in footage from the real deal. And I would guess that what they're trying to portray here is the tsunami in Thailand and the tsunami in Japan. The only reason that I say this probably can't be real is that looks like about a 30-story building here, and this wave is about twice as tall. So that would be a 600-foot wave. But it's very scary. So what kind of a problem is this? Is it a technological problem? Come on, be brave. It's 50-50.
I feel like it's a natural problem
Okay,
because
so
you
for
can't
our
control-
purposes, who's that? So I was going to say, for our purposes, we're going to call this a natural problem. That this is a tsunami that was triggered by an earthquake off the coast. I'm guessing this might be Japan. Doesn't particularly look like Thailand. So let's go to the next one. What's happening in this picture? Is it a technological problem?
Natural.
Natural. Who is that? Come on, be brave. Somebody had the right answer. Natural. All right. Every time I'm looking over to your left, my right, I'm staring at my fabulous new extra screen so I can see everybody's faces. Okay, so both of these could be interpreted as a technological problem. The first one could be resulting from ocean rise or something. And this could be that a giant meteor slammed into the other side of the world, or Dr. Evil caused the moon to slam into the other side of the world, and it's causing volcanic eruptions on the opposite side of the impact. That did happen with the meteor where the dinosaurs died. But we're saying this is a natural problem. Natural problems are just as significant, even possibly more pervasive than technological problems. Okay, here's an interesting one. What's happening in this picture? Is this a technological problem? There's not a lot of labeling, so it's going to test your memory. And for you guys, this probably happened a while ago. So what this is showing is down on the bottom of the globe at the South Pole. This is Antarctica in here. In 1979, the world's atmosphere is relatively green and okay. By 2006, there doesn't seem to be a lot of atmosphere here. It's very clear compared to 79. What's going on there? What caused that? Does anyone remember? Oh, I think someone's trying to get in. Oh no, I've covered up my things. There's Cheyenne. Come on back in, Cheyenne. So sorry about that. I'm covering up my nice things. I have a new screen, but I'm not using it to my best advantage. Okay. All right. So somebody needs to be brave. Somebody needs to come up with an idea of what's causing this big hole down at the South Pole. I'm giving you hints. It was called the something hole. It made everyone in Australia have to put on more sunscreen. Okay, nobody? This is an illustration of the ozone hole. This is the idea that, does anyone know why there was an ozone hole? What caused the ozone hole? Nobody? Okay, so what caused the ozone hole was we used to use a substance called CFCs, chlorofluorocarbons, as a propellant for aerosol sprays. That's what pushed the stuff in your spray can out, was CFCs. So they came out along with whatever you were spraying out of your can. CFCs, no one knew at the time, but were later found to be incredibly damaging to ozone molecules. Ozone is oxygen that has been converted into ozone. Oxygen in its natural state is O2. When you expose oxygen to ultraviolet light from space, from the sun, oxygen models get bombarded and you can create O3. O3 is a triple oxygen molecule and it is ozone. It's actually very poisonous to humans. But up in our atmosphere, ozone creates a protective barrier to those gamma rays and radiation coming from space. So the problem was when there was this big ozone hole, people in Australia were starting to get roasted much more quickly than normal by the sun because they weren't being protected from the UV rays coming into the Earth's atmosphere. That's very long-winded. Okay. Is this picture a technological problem?
It's natural.
Okay, I agree. And the thing is, though, there's two ways to interpret this. I believe this picture is trying to show polar bears suffering from climate change and global warming and that their ice is disappearing. But this could very well be just a polar bear up on top of a chunk of ice 50 years ago. So if it's global warming, it's a technological problem. If it's that the polar bear just can't find the right shaped ice flows in its environment, that's a natural problem. Okay, what makes technological problem solving different? Why is knowing the difference significant? So here we have two articles from 1977, How to Survive the Coming Ice Age. This was the idea that ice ages might trigger relatively quickly or much quicker than anyone thought of in the past, and that we might be going into a mini ice age or something. Then in 2006, this is an article about global warming. You know, be worried that there's not going to be any ice left for polar bears. So what makes technological problem solving different? Why is knowing the difference significant? Can someone try and answer that? I know it's not easy. Don't worry, you won't be wrong or anything. How about Ruby? We haven't heard from you, Ruby. Ruby, do you have any idea on this? Why is technological problem solving different from natural problem solving?
She just told me that her volume doesn't work.
Oh, okay. No problem. Let's find another suspect. Elita Bain. Bain? Is that right? Elilta, I'm so sorry. I have bad eyes anyway. Elilta, is that the right way to pronounce your name? Elilta Bain?
No.
Okay, how do you pronounce it?
Alota.
Elilta, and your last name?
Bayane.
Bayane. So it's each letter. Perfect. Thank you so much. What's your idea for what makes technological problem solving different, and why is it significant to know the difference between a natural and a technological problem?
I guess like with a natural problem, like you can't really, like with an earthquake or a hurricane or a tsunami, you can't really like do much to stop it. Like it's gonna happen regardless. But like with a technological problem, like you could with the help of others, like you could find a solution for it, and it's like a problem that you actually can solve.
Perfect. That was a beautiful explanation. So it's the idea that natural problems you typically can't solve, or that they are so complex that it will take years to solve the problem. So say something like pollution in the Chesapeake Bay. The Chesapeake Bay is one of the jewels of America. It's a giant bay that's only 60 feet deep at its deepest. That means the sunlight gets down to the bottom almost all the way through. But it has been so polluted that there are dead zones in there and all kinds of stuff. The Save the Bay initiative has been addressing pollution in the bay, gotta be 30, 50 years. They are succeeding, but it has taken them 50 years to try and address this because they're dealing with trying to solve all the pieces that are contributing to pollution. With a technological problem, it's usually simpler, that usually there is more of a single source that can be addressed. Okay. So what makes technological problems different? The goal is not to expect everyone to know or find a fixed answer or set of answers, but it's, what do you think comes next? Nelson Ramos, I'm going to pick on you. What do you think comes next? The goal is not to expect everyone to know or find an answer to the technological problem, but it's what? I'm going to say it's easier to something. Any idea, Nelson? Sorry to put you on the spot. This is a tough one. Joey Nickel, do you have any ideas of, with a technological problem, you may not be able, everyone may not be able to find a fixed answer or set of answers, but it's easier to what?
I guess easier to find a solution when you have different people thinking together.
close, but not quite. What I'm thinking, that's a great idea. It's easier to find the source of the problem. It's easier to point at what is causing the problem because it's a technology that you can point to. But that was a nice answer because so the first place you go in your engineering design loop is establishing or in our technological problem solving, is establishing what the problem is. The next step is the brainstorming what we're going to do to address the problem. So you were just one step off which part of this we're in. And this is confusing. I don't find the way this lecture is presented to be perfect to me, but I think it helps and it gets us thinking. So what makes technological problems different? Goal is to invoke critical questions from a citizenry that need an academic answer with integrity. That seems a little weird. Saying the goal is to invoke critical questions from a citizenry that need an academic answer with integrity. I'm not really sure what that's saying, other than you need the people that are experiencing the problem to get a solution that makes sense. But let's see here. Because critical thinking to a technologist says even choosing to ignore the problem, there is going to be a loss. That loss will come to human life, one's quality of life, or vital resources. So deciding not to solve a problem has consequences too. So, I don't want to be political, but let's say, our current administration, their posture is pretty much denying that climate change exists. The problem with that posture for everyone else is that their denial does not solve the problem that many people feel is coming. So when we decide not to solve a problem, there will be a cost. And that cost can come in human life, one's quality of life, and vital resources. So these are ways that people have been, hurt by technological problems. Those are probably kids that have suffered from landmines and spare munitions in war zones like Vietnam. This vaguely looks like Bhopal. I think that might be a nuclear stack over there. Bhopal was a big industrial complex for Phillips 66 in India, in Bhopal, India, that there was a toxic cloud that got released and killed everyone surrounding the factory. That was a technological problem. But just remember, the loss will come to human life, one's quality of life, or vital resources. This is definitely an oil spill. So, okay, we've got 10 minutes left. Technological problem solving. Many times solving a problem does not always seem to have an obvious or common starting point. But technological problem solving does have hopefully an obvious, but a common starting point. It starts with identifying the problem. That's what I was saying is the great thing about technological problem solving. You start with identifying the problem, and ideally it is an identifiable problem. Then you follow a set of steps towards a solution. There's planning, there's action, there's analysis, there's causes, there's issues, there's outcomes, there's ideal resolutions, there's options. Technological problem solving can be defined as human knowledge generated and applied for solving perceived problems and needs. So that's a pretty good, simple definition. Technological problem solving is defined as human knowledge generated and applied for solving perceived problems and needs. That pretty much seems like an explanation of any problem. Does not seem like it's exclusive to technological problem solving. That if we're solving how to predict the weather, human knowledge generated and applied to solve a perceived problem seems to work to me. And that's solving a natural problem. But you get the idea. We're using our brain power to apply it to solving what is the perceived root of the problem that is affecting us. This is called a feedback loop. You have a problem, you create a technology to hopefully solve that problem, you deploy that technology. The technology solves 80% of your problem, but it doesn't solve 100%. So you still have 20% left over. You need to start your loop again. Think about what the problems still are. How are you going to fix that? How are you going to create something that will fix that? How do you test something that's going to fix that? And how do you do it? And it goes back again. You know, now we're 95% good. But that's the idea, that problem leads to technology. Technology ideally solves problem. But it's never clean. You're never 100%, you know, oh, this technology is going to solve the problem and there is never ever going to be another issue. There's little bits and pieces that it won't solve, that will still remain, and then you need to figure them out. This is, I think, just about the end. Technological problem solving techniques vary, but identifying the problem is always step one. Design brief, a statement of the initial problem. You want to put the problem down on paper. Criteria for evaluation. You must relate to the design brief how you are creating the solution. Trial solutions. You make sketches. You create little experiments. You do mock-ups of how you're going to solve the problem. You select the preferred opinion. You talk with your group. You get those different perspectives. And you decide to go with the one that everyone agrees on, seems like it has the most promise. You create a work plan, a schedule of operations. I actually have a PMP certification. That's a project management professional certification. And that is related to my ability to break a task down into its component parts and create a workflow that will combine those component parts on a schedule. So once you've created your plan, you need to execute your plan. You go in a room and you try and figure out solution. Genius is at work, do not disturb. You journal, you keep a record of what your ideas are that you're coming up with, and then you present your solutions. You present, the designer and the client have an evaluation of, here's my product to fulfill your needs. Did it work? Something you'll learn in the design process is a lot of times the designers get carried away from what the client wants. A lot of times that's called gold plating, adding things they didn't ask for. Sometimes when the manufacturer delivers the product to their client, it's not what the client wants. So typically, you're going to have to review it. There's going to be problems in your prototype. You're going to talk to the client. You're going to make sure everyone's on the same page as what needs to be fixed. Then you're going to go back through this whole loop again. You're going to think about your problems. You're going to evaluate what's still a problem. You're going to create solutions to them. It's a loop. It keeps happening. Technological problem-solving techniques we will be studying include invention and innovation, research and development, and experimentation. Technological design challenge techniques we will be using include design folios, design briefs, and technology learning activities. All that's left is the power of positive thinking and positivity from you. Okay, let me get out of here and just show you that we do have a quiz for homework. It's very simple. Ideally, I've gotten it so the right quiz is in here and you guys can now see it and access it. So this is the preview. It's going to be the same thing that we did last time for a quiz. The quiz, even worse than me giving you the highlights of what it is, seems to have technological problem solving in the title. So that is our vocabulary term for this lesson. So let me know the vocabulary term, technological problem solving, how it is defined in your mind. You can look it up. If you want to give me like a dictionary definition, let me know where you're getting that from. Otherwise, use your own words. And just from our conversation, and I apologize, this has been a little one-sided, let me know what you think technological problem solving involves. The last one is just a photo of what you see as technological problem solving. And then how comfortable are you with this term? That's it. It is 1:28. Does anyone have questions? Anyone want to talk about your project? Next week, I think we'll start looking at our projects and how we're going. And we'll probably spend most of the class working on our presentations and where we should be looking, what kinds of things we can find, all those kinds of things. It should be really fun and creative. Does anyone have any issues, questions, problems?
I have a question. Are you going to post the rubric for the project, or should we just go back and watch this recording?
The rubric for the project is right in the instructions for the project. So hang on, here we go, back in. It's what I read this morning. Hang on, so right here. When you go into the module, hang on, that's not where I want to be. I think this one's. So, that's.
Oh, okay, I found it. Sorry, I wasn't.
Okay, no worries. But it's right here, and the rubric is basically the project guidelines. 5 points to describe it, 5 points to describe the function of the project, 5 points to explain why it was developed during this time period. Why is this a particularly interesting technology of that era or age, and include an image of the item. So this is going to be as fancy or as simple as you want. Some of the things that we've discussed before is the idea that you might want to follow a technology through time. We thought of looking at how light has changed from the Stone Age to the Information Age, how weapons have changed, how medicine has changed, how clothing has changed, how art has changed. What doing that does is it lets you get a better idea of how each generation adds to an older technology and comes up with new and different innovations. Most innovating is not coming out of the blue. Most innovating is looking at an old product and creating a better version of it. So this is totally optional and up to you, but if you follow one thing through time, you'll get to understand a little more about how things progress through time in terms of a technology. Otherwise, you can pick totally different random items from each period. Hopefully, they are items or a technology that speaks to you, that interests you, that you find fascinating. I want this to be fun. I want it to be engaging, because this is a real chance to go looking through time at how these people in these different time periods were thinking and what were their big problems. What did they have to solve? A lot of it with weapons is somebody keeps coming and trying to take my stuff. How do I protect myself? Okay, we're in great shape. That's it. Everyone can go. For tomorrow, if you have questions, I'm finally looking at the right sheet. Our check-in time is 1:45 to 2:05. That is going to be using just our regular class link. The other exciting thing is I sent an email to everyone. Let me just quickly show you. I have put all our lectures into YouTube for us. So when you go to the home page of our class, you hit home, scroll down, class overview. Right in the top, link to FOT class videos. Click this link. It is going to take you to the YouTube playlist that is going to have all our videos in order. from the 11th, from the 8th, from the 2nd, and the 1st. Okay? You can click on whichever
It's not
video
so
you
clear
want to
for you.
see, get my
Let's get
epic
to it.
personality. But that's a great resource, and I just want you to know that it's there. It's also in an announcement in the announcements. Okay, sorry for the false departure. Thank you. Run away.
Thank you.
Bye.
Goodbye.
Bye. Thank you.
You bet. See you next Friday.
I have a question.
Yes, absolutely.
So last week for one of the assignments, the
Yep.
virtual checking warm-up thing, I was wondering if you got it because I submitted it and everything.
I don't know. I haven't looked. Let me write down. I would not be too worried. Right now, I am new to the MCPS system, and so I am still getting equilibrated to everything. I am behind on the grading. No one's going to be trying to punish you for grades in this first month. We're really trying to just give you good stuff that is going to help you move forward and get everyone on the same page. So thank you for giving me the heads up. I will double check that. And that is the warm up from last week.
Okay, thank you so much.
You bet. My pleasure.
Have a good day.
You bet. Nelson, is there something I can help you with? Nelson? Nelson? Okay. Okay, I'm running away. Have a great day. I'll see you on Friday.